In Lab 5, page 2, we're going to right mouse click and we're going to copy link. Then we're going to go to Kyle Studio Cloud and we're going to clone and right mouse click and paste it in here. It's going to come in as Lab5b and make it the active project. And what we want to do is take a look at lab5b.cpp. Now the first thing we want to do is set up our build target here to Freedom K64. Second thing, we want to connect our hardware as well to the Freedom K64. Once we've done that, the next thing we want to do is actually go up here and debug our project, but you'll find this is experimental. And the way to get around that is if there's any problems, you can just go help, log out, and come back. And probably 99.99% of the problems that the debug is going to give us, because it's experimental, will go away. Now this program is going to show us raw data coming from the pot. The pot is going to use the read function for analog in, which is going to return a value from 0 to 1.0 as a floating point number. And the equivalent voltage, if we multiply this value by 3.3, that's going to change 0 to 1 to 0 to 3.3, which is the voltage range that we've got. So on our LCD, we'll have 0 to 1 and 0 to 3.3 volts, which is the equivalent voltage. You can see our include section here has grow backlight and embed.h. And we have a function prototype section here, which we're going to use later for dealing with serial monitor in a later part of Lab 5. Here's our hardware definition section. And we've got our analog in, constant integer max. And integer max here is 20, which is more than enough characters because we only have 16 characters on our LCD display. Now, what we're going to do is we want to actually over here, instead of just running our code, we want to go over here and debug our project. So before we go to our debug, what we have to do with our variables is we're going to have to make them volatile. And the reason why this is that if we don't make them volatile, because this is a microcontroller, not a PC, it's going to try and move these values that would normally go in the variables that are in RAM. It's going to go through CPU registers to try and save RAM. So making them volatile is how we're going to be able to look at what's really going on in here and not have any problem following what's going on. And what we're going to do is we're going to set a breakpoint here. And what we're going to do is now go up here and hit debug project. And when it's finished, you'll see it switch over to the debug mode and we'll pick it up at that point. Now you can see that it's actually switched over now to debug mode, but until we get the arrow coming up here, it's not ready. Now it's ready. Now what we want to do is take a look and see how these variables are going to change as we go through the code. And this is our step over button. So if we step over this, we're going to find a buffer is our character array. Notice that there's garbage in it, because arrays and variables such as voltage and voltage 1 here are in RAM. And RAM is full of random stuff, and it's going to have random values in it before you actually set it to something. And so right now, this is random here. These numbers in voltage and voltage 1 are random, times 10 to the minus 315 times 10 to the minus 154. So if we run, and I'm going to set a breakpoint here just to see, and I'm just going to hit the run button. It's going to run down to that breakpoint. And you can see that now buffer is changed to all zeros. When we step over this command here, it's going to do the LCD clear, and it's going to then do the LCD locate, which is going to be up on the top left corner of our LCD. And right now it's going to try doing a sprint F. Now what I'm going to do is I'm just going to set a breakpoint down here on line 33. And I'm going to run down to that breakpoint. And you can see here that it's got reading voltage with a null at the end. And that is what has been printed up on our LCD. Now at this point, we're going to change our LCD color to blue. So if I step over this, you can see our LCD is changed to blue. And once we start doing things like pot read and so on, so let me just set this down to here, to line 41. What we see here is it's changed all the characters that were here from reading buffer to the actual value 0.983 and 2 spaces because we had 2 spaces in here. And then it's 3.273 with a null at the end here. So this becomes our string that we can print out. And as soon as I trace on to the next line here, LCD print, you can see that those are the values that are coming up formatted as this %5.3f and 5.3f here.